Here we have a library of functions. For each function, we'll graph it. We will identify the domain and range, the intercepts. We'll determine whether the function is odd, even, or neither. We'll determine the intervals over which the function is increasing, decreasing, or constant. And finally, we will identify any absolute maximum values or minimum values. We'll start with the function h of x equals x squared. And that's a parabola. And several points on the parabola are 1, 1, let's see, 2, 4, negative 1, 1, and negative 2, 4. The domain equals x, and now there's no possibility of division by 0 since there is no variable in the denominator. Also, there's no possibility of taking an even root of a negative number, so the domain is all reals, or x element of the reals. The range equals the set y such that, and the minimum y value is 0, and this function will take on all y values greater than 0, so y is greater than or equal to 0, and that's the range. C. The intercepts. Well, the x-intercept is at 0, and the y-intercept is at 0. This function is symmetric about the y-axis, so it is even. If it was symmetric about the origin, then it would be odd. The intervals on which this function is decreasing, well, that interval is negative infinity to 0, always an open interval when we talk about increasing or decreasing. And it's increasing on the interval 0 to infinity. Finally, we have a absolute minimum, so ABS min at 0, 0. The graph of the function m of x equals x cubed looks like a parabola, except one of the arms has been flipped over the x-axis. So we've got symmetry about the origin. But to start with, the domain, D equals the set x. And again, there's no possibility of division by 0, nor is there the possibility of taking an even root of a negative number, so the domain is all reals, or x element of the reals. The range equals y, the set y, and notice, just by observing the graph, this graph goes in a negative direction forever and in a positive direction forever. So the range is y element of the reals. They're all real numbers. The intercepts, well, we just have one intercept here. It's at 0, 0, so the x-intercept equals 0, the y-intercept equals 0. As we said, this function is symmetric about the origin, so it is odd. As to increasing and decreasing, this function is increasing on the interval negative infinity to infinity. And finally, there is no absolute max or min. None. For the function n of x equals the square root of x, we have the corresponding graph. Several points on this graph. One of them is 1, 1. Another point is 4, 2. As to the domain, D equals the set X such that, and clearly we cannot take the square root of a negative number. We can take the square root of 0, which is 0. So X is greater than or equal to 0. The range equals the set Y, and by inspection we can see that all Y values greater than or equal to 0 are on this graph. So Y is greater than or equal to 0. The intercepts, well, we have one intercept again at 0, 0, so the x-coordinate of that is x equals 0, the y-coordinate of that is y equals 0. This function is not symmetric about the y-axis. It is not symmetric about the origin, so it is neither odd or even. Neither. This function is increasing on the open interval 0 to infinity. By the way, I must point out that we talk about increasing or decreasing in intervals. That interval is always in terms of horizontal coordinates, not in terms of vertical coordinates. So 0 to infinity. As to an absolute max or min, there is an ABS min, absolute min, min at 0, 0.